Hi there, Desiree Gowell here, Master's student studying Natural Resource Management at Cairns JCU. So I've recently taken an interest in working with GIS, and I want to share with you today how it can be applied to managing our natural resources, using a local case study from the Wet Tropics World Heritage Area, and how GIS can be used and is being used to stop the spread of yellow crazy ants.
So yellow crazy ants are declared a Class 1 pest under the Land Protection Act and listed as one of the world's 100 worst invasive species. They are incredibly aggressive. Moving in large supercolonies, they can annihilate nearly all invertebrate life, starving other animals depending on them for food, and they can easily wipe out lizards, frogs, and nesting birds. YCA clearly poses a serious threat to the outstanding universal value of the Wet Tropics World Heritage Area. However, biodiversity isn't the only element under threat. YCA have impacted on the sugarcane industry as they promote the growth of scaly and boring insects that damage crops, therefore reducing yield and farmers' profitability.
So once we understand the species ecology and biological characteristics, GPS and GIS can be used to determine their exact distribution, from which maps can be generated to guide a successful eradication program.
Raw location data obtained from social and on-ground surveying with GPS units are in the form of waypoints, which are downloaded to our GIS and projected onto a map, revealing suburban YCA distribution. Overlaying location points and GPS tracks onto an aerial photograph allows easy visualization of the ant habitat preferences. For instance, here we can see the red points depict positive sighting and green negative. There is a higher abundance in heavily disturbed areas near residential buildings, along cleared riparian zones and in sugarcane farmland. Adding a digital elevation model to the equation can reveal rugged hillsides and flat plainlands and river tributaries. From here we can identify potential pathways for spread, illuminating creeks as a likely facilitator of dispersal as well as vegetation openings at the base of the World Heritage Area. Alarm bells are ringing because we can also see here that the ants have progressed nearly 70 hectares into the World Heritage Area. If the ants reach Coppersloe Dam, they will be unstoppable, using connecting streams to raft and disperse. YCA distribution maps revealed that the main infestations around Edmonton and Bentley Park cover roughly 800 hectares of rainforest, sugarcane and residential estates. It also indicated that some terrain is too dangerous for surveying crew to operate safely on the ground. The inaccessible location of these colonies means that baiting must be done by helicopter. But before aerial and on-ground baiting can be carried out, infestation boundaries must be delimitated. Using a GIS buffer, we can extend the known infestation frontier by 100 metres from the furthest positive points to ensure the entire infestation is contained within a georeference treatment area. A buffer can also be applied to creeks to prevent contaminating the waterways. These delimitation boundary coordinates are hooked up to the helicopter GPS, guiding the pilot with accurate precision on where to fly and drop bait. If there happens to be an obstruction on flight day and the pilot needs to avoid a particular section, we will see the gaps in flight paths in the return GPS coordinates. These gaps are identified on maps and given to the on-ground action crew who will manually lay bait in gaps and along the creek buffer zone. GIS mapping really is a lifesaver in managing the financial costs of such funding-intense programs. Over 5 years, this eradication program was funded a tiny $2 million from Australian government. Given that $60,000 is allocated to Green Army groups to conduct on-ground baiting, $150,000 funds roughly 1 weekend of aerial baiting, and just one 12-kilo bucket of bait costs $500, it is imperative that all aspects of the eradication program be on point. Generating maps with accurate boundaries and helicopter navigational routes ensures the pilot's time is used effectively. There must be no windows left open for small mistakes in an operation like this. Bait lines are drawn to precision, ensuring no overlap and eliminating the chances of doubling up and wasting resources. It also ensures bait is dropped exactly at the delimitation border to limit spread and drastically reduce impacts on non-target species. So recent surveys and GIS modelling has confirmed that 3 sites once heavily infested with YCA are now ant-free. The commitment from the Wet Tropics Management Authority and the partnerships they formed with various operational, conservation and volunteer groups is extraordinary. The energy and effort has sent waves crashing through politician chambers, and the Australian government has finally recognised the fatal impacts yellow crazy ants will have on our valuable natural asset if left untreated. On Thursday, the YCA eradication program was funded $8.8 million for another 5 years.
So I really hope I've sparked an appreciation for GIS today. It is tedious work, but as you've seen, is a critical tool for conservation. Managing invasive species is just one of the many applications of GIS and natural resource management.